Hi Danielle, I'm going to go ahead and solve this problem for you to show you how something like this would work. So if you're asked if this function is differentiable at x equals 7, what I would first do is just do a really quick graph of the function. Doesn't have to be that detailed, but just a really quick sketch. So to be able to figure out what this function looks like, you're going to simplify f of x equals x squared minus x minus 42 over x minus 7. So to simplify that, if you factor the numerator, that factors to be what? X minus 7, x plus 6 over x minus 7. So, you see how the x minus 7's cancel? So that graph actually simplifies to be the function f of x equals x plus 6. But since x minus 7 was in the denominator, you still have to exclude it from the domain. So this graph is just going to be the line f of x equals x plus 6. So you're going to have 1, 2, 3, 4, 5, 6 is your y-intercept, and it's going to be a slope of 1. So your graph is going to look something like this. But when x equals 7, you have a hole. So when x equals 7, 1, 2, and again, you see my graph is not that accurate, it's not that big of a deal. There's going to be a hole in this graph. So your graph is going to shoot off in that direction. But it does not exist at x equals 7, because if x was equal to 7, then this function, the original function, would be undefined. So that's the first half of the graph. Then we have the second half of the graph. F of x equals 5. So f of x equals 5 is just going to be a point at x equals 5. I mean, so a point, or no, I'm sorry, not a point. It's going to be a line. F of x equals 5 is the same thing as saying y equals 5. So y equals 5 is 1, 2, 3, 4. Just going to be a line right here. So if we're asked if this function is differentiable at x equals 7, do you see that not only is this graph not continuous at x equals 7, it's also not differentiable. Remember, for a function to be continuous at x equals 7, that means you would not have to pick up your pencil at x equals 7. And do you see when we're drawing this line, so we get to x equals 7, we pick up our pencil to skip over x equals 7. So that disqualifies it from being continuous. Also, remember, if a function is not continuous, it's definitely not differentiable. It can be differentiable, and it can be continuous but not differentiable. Like, for example, remember if you have a graph that looks like this, that's continuous, like, and let's say, you know, if this was your point, if they were asking you, is the function differentiable at x equals 0? This graph is not differentiable at x equals 7, but it is continuous. Okay, so here's another problem that's kind of similar, but a little bit different. So if you're asked to find if this is continuous and or differentiable at x equals 5, first, again, you want to just graph the two lines. So in graphing the two lines, you see x plus 15, so let's count this as 5, 10, 15. Our y-intercept is going to be 15, and our slope is going to be 1. This graph is true between -5 and +5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're going to go, let's see. Okay, so for when x equals +5, y is going to be 20. So if this is 5, 10, 15, 20, x equals +5, y is going to be 20 right here. When x equals -5, y is going to be 10. Right? So that's where this line starts and ends. Do you see that we're going to have a closed circle at -5? and also a closed circle at positive 5. So that's going to be our line for the first equation. Now for the second equation, y equals 4x. Our y-intercept is going to be 0, and we're going to rise 4, run 1. So we're going to go just below 5, just below the beginning hash mark. That is going to be true between 5 and 8. So to figure out where that line starts, we plug 5 in for x, so it's going to be 20, right? When x equals 5, y equals 20. X equals 5, y equals 20, which is up here, right, which is the same place. So do you see we'd have an open circle at 520, which is the same place that this line ends? And then when x equals 8, y equals 8 times 4 is 24. So this is 20, so wait, okay. So if this is 5, this is 10, this is 15, this is 20, this is 25. So we're going to be going up to 24. At 8, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So 8, 24. So do you see that our graph, the second part of the graph looks like that? Now the question is asking if the function is continuous at x equals 5. Yes, and do you see as you're drawing your line, as you're drawing a line along this graph, you don't have to pick up your pencil at x equals 5 because you've got an open circle on top of a closed circle. So you never pick your pencil up and you continue drawing. So yes, it's continuous. But is it differentiable? It is not differentiable because do you see, even though it's a very slight change in slope, there is a change in slope, which means there can be more than one tangent line to the graph. And because there can be more than one tangent line to the graph, it is not differentiable. Remember, to be differentiable, there can only be one tangent line, and that tangent line cannot be a vertical line. Because remember, if the tangent line were a vertical line, so there must be one tangent line, not vertical. Because if the tangent line were vertical, remember, a vertical line is not a function. So it doesn't have a slope. So if the vertical line didn't have a slope, then you wouldn't be able to get the derivative. So for that reason, it's not differentiable. But in this case, it's not differentiable because there are multiple tangent lines to the graph. So I hope this answers your questions, and hope you're having good luck studying for the test.